You've heard about Rust. It's fast, it's safe, and it's taking over systems programming like a storm. But what's the hype really about? In this lightning speed crash course, we'll walk through the absolute essentials of Rust using real code, line by line. We'll cover everything from printing output, using variables, loops, functions, and even how Rust compares to languages like Java or Python. So whether you're a beginner or just Rust curious, strap in. This is going to be fun, fast, and full of code. Let's go. So why are people obsessed with Rust? Well, Rust is a systems programming language that combines performance like C++ with safety like Python. You get memory safety without a garbage collector, and that's a big deal. It's used in places where speed and reliability matter, like game engines, web browsers. Yes, parts of Firefox are written in Rust. Operating systems, embedded systems, and even command line tools. Some of the biggest wins of Rust: memory safety without runtime overhead, no nulls, no data races, no surprises. It has great tooling, amazing compiler messages, and a super active community. Basically, Rust is built for those who want both control and safety. Every Rust program starts from the main function. This is the entry point, just like in C or Java. It's defined using fn main. The fn stands for function, and the empty parentheses mean it doesn't take any arguments. We wrap the function body in curly braces, just like C-style languages. Here's our good old friend, println. This is how you print output in Rust. Notice that exclamation mark at the end? That's because println is a macro, not a regular function. Rust macros are like power tools. They let you do things functions can't. This line prints hello world to the terminal. Simple and classic. In Rust, you declare variables using the let keyword. By default, Rust variables are immutable, meaning once assigned, their values can't be changed unless you explicitly say mut. Here we've got a mix of types. Age is an integer, pi is a floating point number, name is a string slice, and as fun as a boolean. Rust is strongly typed, but it's also smart. It figures out the type for you unless you want to be explicit. This is how you interpolate variables into a string. Just use UR placeholders and pass the values in order. This is similar to formatting in Python or JavaScript. It's safe, clean, and readable. Rust won't let you mess up the number of placeholders. Compiler to the rescue. Strings in Rust can be tricky, but here's a simple use case. We're calling .to uppercase to make hello uppercase, and then printing it along with its length. Notice that greeting becomes an owned string, not a string slice anymore. And yes, strings in Rust are UTF-8, which means emojis and international text just work. Functions are declared with fn. Here we have two examples. Say hi takes a string reference, and ampersand stunctor. That means it borrows a string rather than taking ownership. Add takes two i32 integers and returns an i32. Notice that there are no return keywords here because Rust automatically returns the last line if there's no semicolon. That's super handy for concise code. Now we call those functions. Say hi world prints a greeting, and we call add 510 inside a println to show the result. It's a clean and expressive way to combine computation and output. Rust's if statement works just like other C-style languages. Here, we check if age greater than 18. If it is, we print that you're an adult. If not, we say you're a minor. No need for parentheses around the condition, and curly braces are mandatory for both if and else blocks, even for one-liners. This is a for loop in Rust. We're using the range 1 equals 3, which means it includes 1 through 3. If we had used 1.3, the 3 would have been excluded. So the equal sign really matters here. Nice and elegant syntax for iteration. Here's a classic while loop. We declare j as mutable using mut, then keep looping while j is less than 3. Inside the loop, we print the value and then increment j. This feels very familiar if you've used Python or C before. So how is Rust different from other languages like Java, C, WAS, or Python? Let's break it down quickly. No garbage collector. Rust uses ownership and borrowing to manage memory without pauses or collection cycles. Compile time safety. A lot of bugs you'd only find at runtime in other languages, like null pointer exceptions, are caught at compile time in Rust. No classes or OP by default. Rust is more about composition and traits rather than inheritance. Performance. You get C-level speed with safety included. In short, Rust forces you to think more clearly about memory, ownership, and data access. But in return, you get rock-solid, high-performance code. And that's it. You just learned Rust in 200 seconds, or close enough. We saw variables, loops, functions, and how Rust stands out from the crowd. This was just the beginning, but now you've got the basics down, and you can start building cool stuff. If you enjoyed this crash course, hit that like button and drop a comment with your favorite Rust feature. Thanks for watching, and I'll see you in the next one.